In this tutorial we're going to look at constructor inheritance in C++. The bottom line here is that constructors are not inherited in C++ by subclasses, but they are called. So let's take a look at that. So I'm going to create a class here called machine to be like a sort of generic superclass, and I'll give machine a constructor. So let's say machine like this, and in the constructor let's put a cout so we can see it running. Let's say machine no argument constructor called, and so now we can already create a machine object. We can instantiate an object from the machine class like that, and if we run this we're going to see the machine constructor running. Let's create a subclass of machine. So let's say class vehicle. So a vehicle is a type of machine, unless it's a magic flying carpet, but usually a vehicle is a kind of machine. Let's give this a constructor too. So I'll just copy this to save me some typing and rename machine in here to vehicle. And let's now create a vehicle. So vehicle. I'm giving the variable the same name as the class here, which I can do because my variable has a lowercase v and the class has an uppercase v. Some people find this confusing and avoid it, but I quite like it if you just got one object of a class, because the class, because I'm giving it an uppercase first letter by my convention that I'm using, which is a common convention, and I give my variables lowercase first letters, and C++ is case sensitive, we are allowed to do this. So let's run this now, and what we find is that well, actually I meant to make this extend machine. Let's do this. So vehicle is a subclass of machine, and also I want all this text actually in the constructor. Let's just change this. Okay, so let's run this now. So now when we actually create a vehicle, the constructor of machine is called first. So we've only got one object here, we've only got a vehicle object, but because vehicle is now based on machine, C++ will actually call the constructor of machine in order to construct vehicle, and it will call it before it calls the vehicle constructor. So C++ will call the default constructors of all the superclasses when it creates an object from a subclass, and that makes sense if you think about it. Let's give machine a private int ID, and the constructor of machine could initialize that ID. Let's set ID equal to 0. Because if we didn't set it equal to something, it would just have garbage in it, whatever happened to be in the memory at that point. So we'll initialize it with 0. And let's also give machine a method called info, which is just going to basically output the ID. So let's say cout ID and ID. And because machine has this info method, public info method, vehicle will inherit that method, so we can say vehicle.info. If we run this now, we find that for vehicle, ID is indeed set to 0. So in vehicle, we can't refer to ID at all. It's private to machine, so we can't do stuff like this. C++ won't let us. We're not allowed to refer to ID in vehicle because it's private in machine, and that means we can only refer to it within the defining brackets of the machine class. So if we run this, then we get an error. And for that reason, it's very handy that the constructors of superclasses are called, because our machine constructor can initialize the private data of machine, and then the private ID of vehicle, the ID of vehicle will be initialized automatically. So let's just build this again and get rid of the error and run it. Whoops, what did I do? Whoops, no, I don't want to do that. I've got an error. Let's just check the error. initializer ID does not name a non-static. I forgot to save my program, that's the problem. Let's run it. Okay, so there we go, right. So vehicle does have an ID. It does have an ID because its superclass machine had an ID. It's just that we can't refer to that ID anywhere in vehicle. We can output it with this method that was inherited from machine. That can refer to the ID. And the constructor of ID can initialize that ID. But in vehicle, we're not able to refer to the ID anywhere. Nevertheless, we can call a method in a superclass that refers to the private data of that superclass, and the vehicle does have an ID because it's inherited it from machine. Let's take this class hierarchy one level further. I'm going to create a specialized type of vehicle, which I'll call car. Let's say public vehicle. So car now is a subclass of vehicle, and it's an indirect subclass of machine. And I'll also give car a constructor. So I'll copy the vehicle one just to save some typing. And we can type car.info. So now if we run this, we find that C++ will call all the constructors of all the superclasses above car before calling the car constructor. So first it calls the machine constructor, which initializes the ID. Then it calls the vehicle constructor, and we can see that running here. Finally, it calls the car constructor, the constructor of the object itself. And again, car has an ID because it's indirect superclass at the top of the hierarchy here. Machine had an ID, but we couldn't refer to that in car because it's private in machine. C++ also allows us to specify which constructor in the superclass at any point in the hierarchy is actually run. So let's imagine, well, let's not imagine it, but actually give machine a constructor that takes a int ID and uses that to initialize ID. So now we can do this. We can do machine, pass it an ID, let's say 123, and of course we can call machine.info. So hopefully I've got this right. Let's run this, and we see that the ID of machine is 123. But we can't call we can't call that constructor with vehicle. So if I change this to vehicle, we can't call this parameterized constructor in vehicle because we only defined it in machine here, and constructors are not inherited in C++, so they're called. The constructors of superclasses are called, but they're not inherited. We can't actually use it like this. What we can do is we can specify in the vehicle constructor what constructor we want to run in its superclass. So let's give vehicle a constructor that takes a parameter, let's say int ID. And I'm going to say here, well, I should change this actually. So this is the machine parameterized constructor. Hopefully I've spelled that right, and I'm going to copy that because it's so difficult to spell. And this is the vehicle parameterized constructor. Now again, we've got a similar problem here to what we saw before, that we want vehicle to have a constructor that looks like this, that accepts an ID parameter to initialize vehicle's ID with, which it inherits from machine. But we can't refer to ID directly in vehicle. We can't refer to this ID because it's private to machine. But what we can do is we can specify here in the constructor initialization that this vehicle constructor is going to run the machine constructor that takes a parameter which accepts an ID. So now we defined this constructor for vehicle, and we've said that this constructor will run the particular constructor in machine that takes a parameter. Let's try running this, see if this works, and make sure we run it. So there we see that the vehicle has got an ID of 123. So this ran this constructor, and this constructor now ran this constructor here. we don't have to call matching constructors in the superclass. So here we've got a constructor that we've defined for vehicle, which takes an ID, and that's calling the constructor a machine, which takes an ID. But we could, for example, in car here, the superclass of car is vehicle, the direct superclass, and in car we could specify that the no argument constructor calls the vehicle constructor that takes an ID, and we could give that an ID like 999. So if we construct a car here, car, so we're calling the default constructor of car, let's call car.info, and if we run this, if I've got this right, then it says car no argument constructor called, that's correct, and the ID of car is 999, because now we've said that the no argument constructor of car calls the vehicle constructor that accepts an ID, so it's running this constructor, and the vehicle constructor that accepts an ID in turn is calling the machine constructor that accepts an ID. Notice that we can't call the indirect superclass constructor of car in the car constructor. So we can't do that, that's an error. We can only refer to the constructors of direct superclasses. So this does work, as we've just seen. To sum this all up, constructors are not inherited in C++. You can't call the constructor of a superclass when you construct a subclass. But C++ will always run one of the constructors in each of the superclasses of a particular class when you instantiate an object from that class. If we create a car, we're going to run a constructor in vehicle, the direct superclass, and we're going to run a constructor in machine. But at each step in the hierarchy, you are allowed to specify which constructor will be called in the superclass. So that's it for this tutorial. To practice this, try creating a multi-level class hierarchy with at least 3 different classes in it, like this, getting more and more specialized. And add some like text, like a cout to each of the constructors, so that you can see that when you create an object, all of the constructors in the superclasses are running. And then try for each level in your class hierarchy specifying which constructor of 2 or more possible constructors that you define will be called when you construct an object from a particular class. So basically have a go at what I've done here, and that will make it a lot clearer in your mind if it's not clear already, which would be completely understandable. And of course you'll get more practice with this when you start to write quite complicated programs yourself. So that's it for this tutorial.